Well, we talked a little bit about relations. Let's see whether we can actually do a little bit of experimentation to see whether we can draw any conclusions about relations. So one way of showing relations between variables is called a scatter plot. So let's return to our talk about young drivers being dangerous. Well, we haven't really proven anything yet, right? Hypothesis that let's state it a little bit neater than last time. The younger the driver, the more likely they are to drive dangerously. So if I look at this, I have two variables. First of all, I have the age of a driver, and then I have the likelihood that they'll drive dangerously. Well, I'm not really sure how to measure the likelihood. So what I could actually do is say, how about the number of dangerous driving or speeding tickets. Now, it may well be that someone is very likely to drive dangerously but just happens to not get tickets, or that someone else is not that dangerous but they happen to have gotten caught. So maybe we can restate our hypothesis as the younger the driver, the more tickets they will receive. Okay, and we can try to see whether that's true. Well, let's say we did a little experiment and we looked into a number of drivers and we asked them how many tickets they had gotten over the years, or let's say over the last 1 year. Now, assuming they all tell the truth, which of course is important for our experiment, we can probably figure out a reasonable answer to our hypothesis. So let's actually get the table here, and we're going to keep track of our two variables. So we have the age of a driver and we have the number of tickets. So we have 10 different drivers. Now I'm not going to actually go out right now and ask drivers. So let's actually stick with 6 just to speed this up. So we have 6 different drivers we're going to ask. One is 16, one's 19, one's 28. We have a 39-year-old, a 52-year-old, and an 81-year-old. Now, for the sake of our experiment, let's make some assumptions that the 16-year-old has had a pretty bad year and actually has had 4 tickets. The 19-year-old has actually had 5. 28-year-old maybe has had 3. The 39-year-old maybe just 1. The 52-year-old maybe has had 2. 80-year-old barely drives anymore and has actually 0 tickets. Well, you may recall how to create a graph or how to create a scatter plot, but if you don't, let's take a little journey here. So we're going to create a scatter plot. So we create 2 axes. This is axis right here, and this is the y-axis. We're not going to keep those there because that's not what we're going to call them. What we're actually going to call them is the age of the driver and the number of tickets. Now, it's actually important which side I put them on, okay? Because the age of the driver is known as a it is known as an independent variable. And what that means is that the age of a driver is not affected by anything else. It's just affected by how old that person is. Nothing else. It's not like driving more dangerously will make me get younger. If that's the case, I think we'd see a lot of dangerous driving out there. It's an independent variable. It's something that can't be changed by another variable. Something like the number of tickets is a dependent variable. It's something that could be affected by another variable. So our hypothesis is that the number of tickets is going to be affected by the age of a person, and we're guessing the younger they are, the more tickets they receive. So we always graph the independent variable on the x-axis and the dependent variable on the y-axis. That's the vertical axis. So let's start age at 16, because let's assume that people are not driving before the age of 16. And we're going to go up by tens all the way to, say, 86. We have 26, 36, 46, 56, 66, 76, and 86. And then the number of tickets, we have 0, 1, 2, 3, 4, and 5. And so now we can actually just graph on our scatter plot the actual data that we've gotten. So our 16-year-old had 5 tickets. Our 19-year-old, and that's bound to be right around here, our 16-year-old had 4. Our 19-year-old had 5. Our 28-year-old had 3. Our 39-year-old had 1. 52-year-old had 2. And the 81-year-old had none. So that's right down here, 0. Well, those dots kind of are all over the place. And I guess they kind of are. But there is a little bit of a trend you can see here. A trend meaning a pattern that I can see on the scatter plot. And that's that it seems that the further I go to the right here, the further down the number of tickets seems to go. Now, it's not an exact line, but there is some sort of ability to see a trend here, or there's some sort of pattern. And I could probably draw a line to this that shows more or less how many tickets a person is likely to get. And that's not going to be an exact predictor necessarily, but it seems like I can probably make a few. So just looking at the scatter plot here, it seems like the age of a driver has an effect. I don't see any older people with tons of tickets. I don't see younger people with no tickets. And so I can probably say that my hypothesis has more or less been proven. But I don't know that. What I'm doing here is I'm making an inference. And an inference means that I am drawing a conclusion based on a couple things. Based on reasoning, so that's just my own thoughts. I'm thinking it out. Based on reasoning and on data. So the data seems to be telling me something here. And based on my own reasoning, what it's telling me is that the older you get, the less tickets you'll have. Or another way of saying that is the younger you are, the more tickets you'll probably have. Now, here's a question. What if I asked a few more people, and I ended up getting a 60-year-old that had gotten 6 tickets, and I found an 18-year-old that had gotten none? Well, it looks like my pattern is disappearing here. If I really want to stick no, my hypothesis is still correct, I could say, well, those are what I like to call outliers. Okay? Sometimes we'll find an older driver that drives very dangerously, and sometimes we'll find a younger driver that drives very safely. But it seems like most people kind of fall into this trend. The dots are somewhat in this pattern. And so if I get dots that are way outside the pattern, I'm going to call those outliers. And all an outlier is a point separated from the main body of data. It means they don't really fit in. So having one or two outliers doesn't really necessarily disprove my hypothesis. It may just be that there's the odd driver that doesn't really follow the pattern. However, if I start to get a lot of outliers, it may well be that my hypothesis is wrong. So I can only call something an outlier if I'm able to prove or to reasonably say that that was an exception rule, that was just one except many, and that overall the rest of my points seem to follow kind of a pattern. So it really only works to call something a liar if it's just in a million. And if I start to get a lot of outliers, they're not really outliers anymore at all. And that's how we can look at a scatter plot to draw conclusions about our data.